The Binomial Theorem, Unveiling the Power of Binomials. The binomial theorem is like a mathematical superhero, coming to our rescue whenever we deal with expressions that have two terms, also known as binomials. It's more than just a formula, it's a fundamental tool in algebra, providing a systematic way to expand powers of binomials. This theorem is the backbone of algebraic manipulations, offering a structured approach to finding coefficients when a binomial is raised to a positive integer power. Let's dive into the intricacies of the binomial theorem, unraveling its formula, understanding its derivation, and exploring its everyday applications. Understanding the binomial theorem, the formula unraveled. The binomial theorem is encapsulated in a formula that looks like a mathematical masterpiece, a pa b, n ta n equals sign 0, nr, nk, nk, b circumflex k. Breaking it down, a plus b, represents the binomial raised to the power n, or nk, is the binomial coefficient, and a, nk, and b circumflex k are terms with different powers. The summation symbol signals that the formula involves summing up terms for all values of k from 0 to n. The binomial coefficient, nk, read as n choose k or n over k, is a mathematical gem itself. It represents the number of ways to choose k elements from a set of n elements and is calculated as nk, n, k, nk. Here, n denotes the factorial of n, which is the product of all positive integers up to n. Let's make things tangible with an example. Suppose we want to expand a plus b cubed. Applying the formula, we get a plus b circumflex 3 equal sign, nar 3 at 0, a cubed b circumflex 0 plus nars 3 at 1, a squared b circumflex 1 plus or 3 at 2, a circumflex 1b circumflex 2 plus 3 at 3, a circumflex 0b cubed. Simplifying each term, we have a 3 plus 3a squared b 3b2 plus b cubed. This expansion showcases the binomial theorem in action, unveiling the power it holds. Derivation of the binomial theorem, a peek behind the scenes. The journey to the binomial theorem involves combinatorial reasoning and a sprinkle of mathematical induction. While the complete proof delves into advanced algebra, we can sketch the process. Pascal's triangle sets the stage for the binomial theorem. This triangular array of numbers, where each number is the sum of the two numbers directly above it, holds the coefficients of the binomial expansion. To derive the binomial theorem, we typically start with the binomial, a plus b, circumflex n, and expand it using the distributive property. For a plus b squared, multiply a plus b by itself, and for a up b cubed, multiply a plus b by a up b squared. This process unfolds until the desired power is reached. To prove the formula, mathematical induction takes center stage. The base case, often equals sign 1, is established, and then the induction step occurs. Assuming the formula holds for n equals sign k, it's proven for n equals k plus 1. This step ensures the binomial theorem is valid for all positive integer powers. Applications of the binomial theorem in daily life. Now that we've unraveled the binomial theorem, let's explore its subtle yet impactful presence in our daily lives. While it might not be as conspicuous as basic arithmetic, the binomial theorem quietly contributes to various aspects of our routines. 1. Probability and genetics. Delve into the probability of getting specific outcomes when flipping a coin multiple times, and the binomial theorem steps in. In genetics, it helps model the likelihood of different genotypes appearing in offspring based on parental genetic makeup. 2. Finance and investments. In the financial realm, especially with compound interest, the binomial theorem calculates the future value of investments. It aids investors in projecting returns over time, considering the compounding effect. 3. Data science and pattern recognition. The binomial theorem is a silent ally in data science, aiding in pattern recognition and classification. It forms the mathematical foundation for algorithms that analyze and categorize data points based on observed patterns. 4. Marketing and A/B testing. Businesses employ A/B testing to compare different versions of products or marketing strategies. The binomial theorem comes into play, analyzing results and determining whether observed differences are statistically significant. 5. Epidemiology and disease spread. In the study of disease spread, epidemiologists leverage statistical models involving the binomial theorem. It aids in predicting the probability of individuals contracting diseases based on various factors. 6. Computer science and error. Correction. Coding theory benefits from the binomial theorem in creating error-correcting codes. These codes ensure accurate reconstruction of data transmitted over communication channels, even in the presence of errors. 7. Sports analytics and performance analysis. Analysts in sports leverage statistical models that incorporate the binomial theorem. It assesses player performance and predicts outcomes, offering insights like evaluating a basketball player's free throw success rate. 8. Quality control and manufacturing. Industries tap into statistical methods, including the binomial theorem, for quality control in manufacturing processes. It helps analyze the probability of defects occurring and guides decision-making to enhance product quality. 9. Biomedical research and clinical trials. In biomedical research and clinical trials, statistical methods rooted in the binomial theorem play a pivotal role. They analyze data to determine the effectiveness of treatments and interventions. 10. Cryptocurrencies and blockchain. The binomial theorem finds its way into financial cryptography and the analysis of blockchain protocols. It models the probability of successful mining and validates transactions in decentralized networks. These examples highlight the diverse applications of the binomial theorem across various domains. Its ability to handle probabilities, calculate future values, and analyze patterns makes it a versatile tool with far-reaching impacts on decision-making processes in both professional and personal spheres. Conclusion. Celebrating the ubiquity of the binomial theorem. The binomial theorem, though rooted in abstract mathematical concepts, seamlessly integrates into the tapestry of our daily lives. From predicting genetic outcomes to fine-tuning investment strategies, this mathematical gem silently influences decision-making processes in fields as diverse as finance, science, and technology. Its applications extend beyond the classroom, shaping the way we understand and navigate the intricacies of our world. As we celebrate the ubiquity of the binomial theorem, let's recognize its quiet yet profound impact on our everyday experiences.